Let's consider the classic children's stories by Dr. Seuss, Horton Hears a Who and How the Grinch Stole Christmas. Both are set in the fictional town of Whoville, which is populated by the Whos. What's interesting, though, is that in both stories, Whoville exists within a speck of dust, and inside a snowflake in some later retellings. The Who's entire reality is held within an entirely insignificant fleck of matter from our higher plane. On the one hand, it's a clever storytelling gimmick to set Whoville apart from all other fictional worlds. However, on the other, it's a possibility that's no longer thought to be quite so make-believe. We're partway through the 21st century, and theoretical science has learned to incorporate a steady stream of new ideas, theories, and breakthroughs. But arguably none has had more of an impact than the ever-growing field of quantum mechanics. The science of the very small, of subatomic particles and physics, has threatened to rewrite everything we thought we knew about how the world works. In general, researchers have continually found that the conventional laws of physics fall apart when we hit the quantum realm, leading to various suggestions as to the structure of the atom, for example, being akin to the structure of the universe. In many ways, both are unknowable. More specifically, however, due to phenomena such as entanglement and superposition, we know that there are infinite potential variations playing out all the time forever at the quantum level. This is especially of interest when it comes to the emergence of quantum computing, as it's thought that the principles at play could one day lead us to incomparably powerful digital technologies. From another point of view, however, all modern research has really revealed is just how intricate matter can be as we travel deeper and deeper inside of it. Perhaps, after all, something like Whoville could be possible. All it would take is a seismic shift in perspective. The shift that's needed arguably happens as soon as you look into black hole cosmology. According to this theory, our entire universe may have originated as a singularity, or a point of infinite density, similar to what we'd expect to discover at the center of a black hole. It then follows that, as this singularity expanded, it created the universe we know today, and indeed is still creating, as we know that the universe is still expanding. To a point, it's a model that follows on from the more general Big Bang theory, which also says that the universe started out as a singularity. The big difference, however, is that black hole cosmology implies 1, a higher plane upon which the conditions for that singularity are made, and 2, that there should be an infinite number of other such singularities, multiplying exponentially as we move up through those higher dimensions. Whenever and wherever there's a black hole, there could, perhaps should, also be a universe. Intriguingly, and as with at the quantum level, the laws of physics inside a black hole are believed to be radically different from those outside of it. For instance, we know that time can slow down or even stop inside a black hole once you move beyond the event horizon. Here, then, we find ourselves in a realm where the unpredictable laws of quantum mechanics become dominant, to some degree, just as they already are in the here and now. The key takeaway, though, is that for black hole cosmologists, the observable universe is the inside of a black hole. Everything we've ever known exists as the eventual singularity, deep within a high enough, massive enough, overriding physical structure. Condense all of that down far enough, and perhaps you do eventually reach a Whoville-like reality, one in which our entire universe is held within just a tiny speck from the point of view of a higher world and a higher being. We might merely be a quantum fluctuation that occurred within a black hole, that occurred within another, and another, and another black hole, and so on, making us and our reality both tiny and bizarrely distorted. It's not as though black hole cosmology is the only theory or concept that's leading us to just such a conclusion, however. Another is that of quantum, or space-time, foam, first proposed by the renowned physicist John Wheeler in the mid-1950s. In short, Wheeler suggested that at the smallest scales of space-time, and we're talking infinitesimally tiny, there exists what can best be described as a foam, the true base layer for physical reality. Wheeler then posited that this foam is made up of constantly fluctuating energy particles forever popping in and out of existence. In more recent times, though, some have pushed this further, asking us to suppose that if these fluctuations can create virtual particles, could they not also spawn entire universes? Some scientists then theorize that within every particle produced in the foam, there could lie another universe with its own laws of physics. Such universes could then be happening and unhappening all the time, birthing and extinguishing in and out of reality, Again, this is a more than interesting idea when considered from our perspective, looking down into the general murkiness of the quantum realm. But zoom out from us to a higher dimension within which all that we know is tiny, and Wheeler's quantum foam asks us again to ponder our true place in reality. Could it be that our universe is one that's also in flux, one that's also popping in and out of existence? And if so, how concerned should we be about it? On the face of it, it would imply that our time is supremely short, that we might suddenly find ourselves snuffed away into nothingness at any moment. But then again, there's also reason not to worry at all. As with the implications of black hole cosmology, any higher structure that's even close to following Wheeler's quantum foam would likely work within entirely different physical parameters. Just as we know that at the quantum level and inside black holes, time becomes distorted and even disappears, we might expect something similar at any version of a higher dimension. This means that ultimately it would matter not how long or short, weak or strong our universe might be from a higher perspective, because from our perspective, it works pretty well. And just as most of us give little thought to the subatomic particles that are constantly churning all around us, any proposed higher entity would likely have very little reason to care about us either. Which finally returns us to the question at the top of today's video. Are we living on someone else's fingertip? Through the lenses of black hole cosmology and quantum foam, it would appear that the answer is quite possibly. For so long as we accept that we don't know everything, and we certainly do not know everything, then theoretical science will continue to question even the most fundamental aspects of our reality. And in this instance, it just may be that if you zoom out far enough, if you climb the dimensions high enough, if you reconfigure your understanding dramatically enough, then our